Good morning, everyone, and once again, welcome to my YouTube channel. Pearson and Excel International Maths by Mr. Kamoto. And in this video, I want to explain something very important, the relationship of circles and triangles. And I'm going to say this, that a triangle has 3 points. We have 3 points in a triangle called the vertices, vertex A, vertex B, vertex C. These are called the vertices. And it is always possible to draw a unique circle through the 3 vertices of any triangle. Any circle that passes through the vertices is called a circumcircle of the triangle. And the center of the circle is called the circumcenter of the triangle. So this is now what we are calling a circumcircle. A circle is passing through the 3 vertices of a triangle is called a circumcircle. And the center of the circle is a circumcenter of the triangle. And it is the point where, and listen to this, the center is the point where the perpendicular bisectors of each side meet. The perpendicular bisector of each side meet. You may be having this bisector, perpendicular bisector. You may be having, probably you put your compass there and you make an arc there, put it here, you make an arc there, center, put it here, you make an arc there, put it here, you make an arc there, and then you drop a bisector of BC and repeat the same, an arc, an arc, an arc, an arc. Then you bisect this other side. Where the 2 bisectors meet, that is the center of the circle. That happens to be the center of the circle. And of course, it is important to highlight some special cases because we have special cases. For a right-angled triangle, of course, when you have a right-angled triangle and you have a circle like this, if you have a circle like this, and then you have a right-angled triangle like that, this is 90 degrees. The hypotenuse of the circle, the hypotenuse of that triangle, right-angled triangle, is always the diameter. The hypotenuse is always the diameter. It is important to note that the hypotenuse is always the diameter. And even if you bisected the 2 sides, you'll realize that you can bisect this hypotenuse. You can call it P QR. You'll find out that by at least 2 bisectors of each side of 2 sides of the triangle, you realize that they meet at this center, which happens to be along the diameter of the circle. And there are 2 ways to illustrate this. You can state these results in 2 other ways. For example, you can say if angle PRQ, angle PRQ is 90 degrees. If angle PRQ is 90 degrees, then R lies on the circle. It lies on the circle with diameter PQ. That is one way of saying it. Another way you can also say, that is one way, you can also say that the angle in a semicircle, the angle in a semicircle is always right angle, is always right angle. There is also another way. You can also say in another way, a diameter of a circle subtends an angle of 90 degrees on the circumference. All these statements mean the same. A diameter of a circle subtends an angle of 90 degrees. This diameter subtending an angle of 90 degrees on the circumference. All these three mean the same. Well, to find the center of a circle given any 3 points on the circumference, you proceed like this. To find the center of a circle given a 3 points on the circumference, you proceed like this. Step number 1, this is to find center given 3 points on the circumference. Well, you could be having a circle like this. Let's just have an example of a circle that looks that way. You could be having that point. You could be having this point. You could be given this point. And the best thing you would do is to join those 3 points with straight lines. And this one with a straight line, any of them. You could join all of them. You could join just 2. The moment you do that, then the second step is find, you could bisect this line. This is A, B, C. You could bisect this line. Let's say there, bisect that line. You could bisect this other one that way, and this happens to be the center of the circle. Of course, that is practically. Theoretically, you can find the equation of the perpendicular bisector, find the equation of this perpendicular bisector of 2 different chords. If you want to find the center of the circle, find this equation of this perpendicular bisector, the bisector probably you have constructed or otherwise. You also find the equation of this other perpendicular bisector. There is this bisector and there is this bisector. Find their equations. And because you know they meet at the center of the circle, find the coordinates of the point of intersection of the 2 perpendicular bisectors. That way, if you find this equation and this equation, you will really solve them simultaneously, and then what you will have is the coordinates of this particular point. That is the center of the circle. If you continue to use the knowledge of simultaneous equations, when you solve 2 simultaneous equations, they will give you this at the point of intersection. They have the same value of x and the same value of y. At the end of the day, you will have realized your perpendicular, your coordinates of the center of the circle. All right.